Good morning. Today we are going to discuss the properties of parallel lines. Last time we talked about the angle relationships that are formed when a transversal cuts through more than one line. Now we're going to talk about what those angles relationship is specifically when the lines are parallel. So we should remember what corresponding angles are. And the rule is going to be that if two parallel lines are cut by a transversal, then the corresponding angles will be congruent. Here are some parallel lines. These are the corresponding angles, or this is a set of corresponding angles. Those two angles are congruent, just like these would be congruent, just like these would be congruent, and these would be congruent. The corresponding angles are congruent. On alternate interior angles with parallel lines. Remember, alternate means opposite sides of the transversal. We also talked about it being opposite groups. These are alternate interior. These are alternate interior. And on parallel lines, maybe I should note that, those angles would be congruent. Alternate exterior angles. On parallel lines are congruent. Okay, and lastly, same side interior angles if the lines are parallel will be supplementary. So I drew this one a different color because it's the only one that kind of stands out a little bit. If the lines are parallel, corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent, but the same side interior angles, like the green ones here or the purple ones here, would be supplementary, which means they add up to 180 degrees. So anytime we have parallel lines cut by a transversal, there are actually only two measures that are going to be formed there, or at most two measures. If they were perpendicular, then everything would be a 90-degree angle. So one of the measures that is given to us here is 113 degrees. Okay, they're telling us that angle 1 is 113 degrees, and we actually have a couple different transversals here, and we are going to figure out what is the measure of all the other angles because of that. So we'll start here. I'm going to write these out. Okay, if this is 113, I should be able to know the measure of angle 2, 5, and 6 pretty easily. Let's start with that. The relationship between angles 1 and 2, they are a linear pair. They should be supplementary. And the supplement of 113 is 67 degrees. So angle 2 is 67 degrees. Angle 1 and angle 6 are vertical. Vertical angles are congruent. So the measure of angle 6 is 113 degrees. Angles 2 and 5 are also vertical and thus have the same measure. Now we're going to start using what we've learned. If we look at transversal S, we can start talking about corresponding angles, alternate interior angles, alternate exterior angles, and same side interior if we would like. So let's just start trying to apply it. This angle 1 and angle 14 are what type of angles? Alternate exterior, if you couldn't tell. Since the lines are parallel, those two angles would have the same measure. So 14 has a measure of 113. And now that we have established that, we could take the 113 and figure out 9, 10, and 13 as well. We'll go ahead and do that. 9 would also have the same because it's a vertical angle. 10 and 13 would be the same. They're also going to be the supplements of 113, so they're going to be 67. So 10 and 13. All right, so we've got all 8 of those figured out. Let's try to transfer it over to the other groups here. And in order to do that, we're going to look at different transversals. Let's look at transversal L and the fact that S and T are parallel. What relationship does angle 2 have with angle 4? Those are corresponding. And we just learned that if the lines are parallel, cut by a transversal, corresponding angles will be congruent. So angle 4 is 67 degrees. That means angle 7 would also be 67 degrees because of vertical angles. And then 7 is supplementary to angle 3, which means it's 113. And 8 is also 113. We just have 4 angles left. Let's try getting to this next group in a different way. We'll look at a different transversal here. Looking at transversal T and noting that L and M are parallel. Something is going on with my Mobi. 8 and 12 have what relationship in this transversal and parallel line set? They are same side interior. And same side interior angles should be supplementary, which means that 12 will be the supplement of angle 8. In other words, 67 degrees. Once we know that, 67 should transfer over to the angle 15 through vertical angles theorem. And then 11 and 16 would be supplements of 15 and 12, which makes those 113 degrees. So as I stated, we would only have 2 different measures here, 113 and its supplement 67. And as long as we have parallel lines, that is going to be the case. Last little example for this very short lesson today, which will be accompanied by another one very shortly after. Let's figure out how we can find the values of X and Y here. We do have a transversal. We also have the parallel lines. And I see that this expression has x in it. So I would like to use another expression of x and see if I can find out how those two angles should relate to each other. Well, those two expressions represent angles that are alternate exterior. That means that on parallel lines with a transversal, those two have to have the same measure. So we write 7x minus 15 equals 4x plus 45. If I solve this using some algebra, we find that x equals 20. Now that we know what x is, I can actually calculate the value or the measurement of that angle. That will be helpful in finding out the value of y. So let's plug in the 20 and see how much that is. 7 times 20 is 140, minus 15 is 125. So this is a 125-degree angle, this one as well. But if this one's 125, what should these two angles do? What relationship should they have? Hopefully you recognize that they're a linear pair and they should be supplementary. So 125 plus 3y plus 12 should equal 180. And we should add all that up together to get 3y plus 137 equals 180. Now we subtract the 137. And we will find that y is going to be left as an improper fraction, 43 thirds, unless I made a calculation error. But I'm checking again. I don't think I did. So 43 thirds is the exact value of y. And this concludes the lesson for today. If you need anything, please let me know.